While migrating, salmon sometimes jump over small waterfalls. Suppose the salmon jumps at an angle of 22 degrees, while 4.4 meters away from a waterfall that's 0.68 meters high. How fast must the salmon jump in order to clear the top of the waterfall? Note, this question is asking for the velocity at 22 degrees. So basically, we have, we have our little waterfall, okay, and our little fishy, and this is the river. Our little fishy is over here. There's a little fishy. And how far away is he? He's 4.4 meters away from the waterfall. And the waterfall is only 0.68 meters high. Okay, and so we know that he jumps at an angle of 22 degrees. And we want VI. Our answer is VI. Notice it's not VIX, not VIY. Our answer is VI. Okay? How can we figure this out? Well, if we knew either VX or VIX or VIY, you know, we've got the vector. This is our answer that we want. If we knew this vector, or if we knew this vector, we could find it by doing trig. We haven't normally been doing that, but trig still works that way. So let's see if we can figure out any of that stuff. Let's write down our knowns. We know delta x. It's 4.4, right? Yeah, 4.4 meters. We know delta y. It's 0.68 meters. We know AY, negative 9.8 meters per second squared. And that may appear to be all that we know. But, thinking about it, if we need to jump over this, that means our final height, our highest point, needs to be the same as or bigger than this. So if this is 0.68, if we need to clear that, we need to jump at least that high, right? So if we need to jump at least that high, obviously the highest point of our jump needs to be there. Needs to clear it. So let's think about what happens at our highest point of our jump. If we throw something up in the air and then it comes back down, at its highest point, its velocity is 0, if you recall. We talked about this in that lab we did a couple weeks ago. So actually, if we're going to clear the waterfall, VFY is going to be 0. So we can solve for VIY, and then we can do trig to find VI. So let's do it. We don't know time, so we're going to need to use VFY squared equals VIY squared plus 2AY delta Y. Okay, but VF is 0, so rearranging this, we get VIY equals the square root of negative 2AY delta Y. So we can just plug in negative 2 times negative 9.8 times delta Y, which is 0.68. This is not negative because this is a distance up this time. So we can just plug in, multiply, see what we get. So I get that VIY is about 3.6508 meters per second. So 3.6508 meters per second. We want this. We know this, we know this. So opposite over hypotenuse, we do sine of 22 equals VIY over VI. We want VI, so rearranging that, we get VI equals, I'll switch colors. VI equals VIY divided by sine of 22. So I'm just going to do that. That number divided by sine of 22. So I get about 9.7456. 9.7456 meters per second. Now let's go check it. I got about 9.7456. And we got it.